All right, so for today, we're talking about the normal distribution a little closer, and 100 was the normal, also known as the average IQ. If you go up one standard deviation, does anybody remember the standard deviation of IQs? Like how much they're different than each other? What was it? Say it.
15.
It was 15. 15 was the standard deviation. There is a little symbol that looks like this on your calculator. That with the X. It's in the list on that one variable stats list. Anyway, if I go up 15, this spot would be 115. This spot is down 15. So it goes down to 85. The cool thing about the normal distribution is that these can always be predicted. There's a total of 68% of people who are between an 85 and a 115. I'll like you to process that for a second. 68% rounds to about 70% of people are pretty close to average. Does that make sense to you? And that's the cool thing, is that you can do this with like shoe size for the whole nation. Almost 70% of people are going to be between these two sizes of shoes. Between, in the brain size, I guess you'd say, for IQ, 85 to 115. 68% of people, always. And so these numbers we're going to give you, I'm going to circle them in red. All of these will be given to you because we don't expect you to memorize them. If you were in a stats class, you might have to memorize them, but we won't make you memorize them. All right, so I wanted to do that example with IQ because I did it yesterday. But what's this really about? ACT scores. And these are actual real numbers from the ACT score in 2010. Look, where do you see the average ACT score on this chart? Do you see the number? It's right there. 21 is the average ACT score. I looked it up for Minnesota because I thought, oh, Minnesota will be better than average. Nope. Minnesota's average is also a 21. But here's the thing. In Minnesota, almost every kid takes the ACT. In a lot of states, only their top students take the ACT. Think about the difference there. Do you get if you only had the top kids take the ACT, your average will be higher? We have almost everybody take the ACT, so it's actually not too bad that we hit the national average ACT score because almost everybody in our state takes it. Some states, only a very small number of really bright people take it, and then their average score looks better. Yes?
Why do they do that?
Because in a lot of states, kids are not going to college, and so they're like, why should I take the ACT? I'm not going to college. That'd be stupid. I don't want to sit there for 4 hours. So a lot of kids don't take it because they're not interested in going to college. By the way, what do colleges want for an ACT score? Well, it depends on the college totally. But I can tell you this. Their ideal is that you have at least a 21 or of course, they like it a little better than average. Wouldn't your college like to say that our kids are better than average? Yeah, so most colleges want at least a 22. But there are colleges out there that'll take, I mean, think about it. This is half of the nation. Do you think that half of the nation doesn't go to college? No. This is actually just half of the kids who took the ACT. So a lot of kids didn't even take the ACT. Of the people who took it, a lot of them are in here. So of course there's some colleges that'll happily take you wherever your ACT score is. Okay, so back to how do we actually get math questions out of this? Here is a typical problem. Are you ready? What percent of people scored greater or equal to 21? Imagine it's a test. What percent of people scored greater than or equal to 21? Would you agree it's all of this? So you just have to add up all of these. And just take a guess what it adds up to. 50%. Doesn't that make sense? Okay. So 50% of people get a 21 or better. 51% of people don't. Sorry, 50% of people don't. All right, now let's do another one. Another typical test question. What percent of people score above a 26? By the way, a lot of people in Minnetonka score about a 26. In fact, that's the average in Minnetonka. Does that mean if our average is 26, do you get there's a lot of kids that have less than a 26? Okay. But this 26 is right here because this is in the nation, and a 21 is average for the whole nation. So the 26.2 is right there. So what I was trying to get you to do is go, oh, so you mean this and this and this.
Like 16%.
Very good. 16% of kids score above a 26 nationwide. You see how this could be handy? You'd be pretty smart if you're able to tell people, well, yeah, 16% of the kids score above a 26. You can look it up on this chart. All right? So answer this for me. I remember one of my students scored an 11 on the ACT, and I was like, holy cow. I was kind of surprised that was a little on the low side. But now that I'm looking at the chart, what percent of people score 10.6 or lower? What percent of people score 10.6 or lower? Did you know I was talking about this and that? And put those together, that's about 2.5% of people. Is that a high percent? No, but if 2.5% of people score below that, what percent score above that? 97.5 is all the rest of it. How'd I do that? I just subtracted from 100%. 97.5% of people score higher than that. That's probably why I've only seen 111. Okay. Last question for you. What was the standard deviation? They never said, but I can tell from the numbers what it was. Okay, would you please look up at the board here? I'm going to highlight in blue the two numbers you need. That and that is all you need. How can you tell a standard deviation from that? Well, because the average is 21, and then how much did it go up? I would take my calculator right there, and if I had a calculator, you guys have borrowed all of mine. Would somebody type in 26.2 and subtract 21?
5.2.
Thank you. Then 5.2 is the standard deviation. Guess how much you subtract to go down to this? 5.2. Guess how much you add to go to this one? 5.2. So that's the magic number. You keep going up a standard deviation, you keep going up 5.2.
Isn't it can't you write it on your calculator?
The standard deviation, yes, it's on there,
This?
and it's the symbol, it looks like this.
Okay.
Okay? That's in your, it's right above the 5-number summary up, a couple of lines up. Okay, so this one seemed pretty easy to me. 50%'s above, 50%'s below. The highest point is the mean, which is the normal. I guess that's one weird thing is that they call mean, which is average, is normal. I don't know, it makes it sound like if you're not average, you're not normal. So I don't really like it, but that's the word they use. The mean is the normal. All right, so let's make our own. Imagine for a moment, I did the survey on this earlier, and I found that the typical kid is right around a size 9 shoe. Let's say, put a 9 right there. Get to the slide, put a 9 there. Participating will make you remember it better. And then let's say I say that I think most kids are going to deviate from average by 2. Let's make our standard deviation at 2. Does that mean everybody's got a size 11 shoe? No, no, no. But if the standard deviation is 2, you should be able to know what goes here, and here, and here, and here, and here, and here. Please write in those numbers. Average shoe size, 9. Standard deviation, 2. Then right away, I know this is an 11. This is a 13. This is a 15. Do you get there's not many people that have bigger than a size 15? Okay, and I subtract 2 and go this way. 7, size 5. Is there anybody at size 5 shoes in here? Okay, so most of you, of course, in fact, I can tell you how many. Most of you are between 7 and 11. Raise your hand if your shoes are between a 7 and an 11. See how that's almost all of us? What is it exactly? 34% this way and 34% that way. And that makes a total of 68% of us are going to be between a 7 and an 11. All right. Do you think that our little class of 20 people is going to have a perfect, exactly normal curve? No. But it'll be kind of close. All right. Do you have to memorize these numbers? No, we provide them on the test. And there it is. In fact, I would like you to take the screenshot capabilities of your iPad right now, because we're going to refer back to this between now and the test. And I'm going to keep saying, you remember that chart? Screenshot it. Then you can go look at the chart. Because nobody's going to remember that this was 13.5. You might remember that the other one's 34 and 34. And now that I challenged you with that, some kid's going to remember it's 13.5. But it's hard to remember all of them. Last one. Typical test question. On my last test, the average was an 80%. That would be a pretty tough test. Most of my tests average a little higher than that. I know because I look at the averages. Where do you put the 80? Right away. Right there. In the middle is true and the top is also true. Yes, it's an 80. Then, what if I said the standard deviation is about a 5? Let's just use 5 because it's a nice number. Do you get this as an 85 then? And this is a 90. And this is a 95. And then, what the heck? There's something higher than a 95? Yes, some kids get 100. You see how this works? So if I told you that it was a 70 or lower is the question. Well, here's 75 and here's 70. 70 or lower would have meant these guys. They're at a 70 or lower. And only 2.5% of people would have been at a 70 or lower. See how that question would have worked? Do you get that the standard deviation was the difference from here to here, so 5? And that the average was an 80, also called the normal. All right, I think you understand it. I could be wrong. Take this one. It says right here what the mean is and what the standard deviation is. And would you please fill in this chart? Use your calculator if you want to. And all I'm asking is that you answer the first question. After you fill in the chart, where 27 goes here, you know, and then you add 1.6 and that goes here. You subtract 1.6 and that goes there. Go ahead, do that. I'm going to pause for a second while you give that a try. And then answer the highlighted question. So then this one will be 25.4. Then I'm going to go down another 1.6. Subtracting 1.6 from 25.4, that's going to be 23.8. And let's just go up by 1.6 here, 28.6. And I've got everything I need. Because as soon as they said between 25.4, which is here, and 30.2, I can know that that's probably going to be right there. Then they're saying these are what I want. So I add up this and this and this. And that makes 68% plus the 13, 78, 9, 80, 81.5. Raise your hand if you had an 81.5. Good. Yay, that's how you do those kinds. Does that make sense to you? All right. If you need help, you can always come up and ask me. There's a worksheet. It's ridiculously short. Not like it's going to take you 5 minutes, but like short enough that I can't cut any problems out or I won't even be having you practice. So I like it because it's small. Get to work. If you need my help, I will be coming around in a few minutes to make sure you're actually doing something. Am I okay at this point with you taking out a cell phone? Yeah, but you need to be working. Kind of a combo. Just do both. That's all I got for your lesson for today.